Find the angle of internal friction. In this problem, a sand sample was tested in a consolidated drained triaxial test, and we've been given the confining stress and the deviator stress at failure. In problems like this one, the confining stress, sigma 3, and the axial stress, sigma 1, are plotted on a horizontal axis and connected by a semicircle. A rupture line is then traced tangent to that semicircle, and the angle of internal friction is determined by measuring the angle between the rupture line and a horizontal line. This same angle is sometimes called the friction angle. For this example, the point where the rupture line and semicircle intersect was arbitrarily chosen. However, any one of these points could have been chosen, resulting in an arbitrary rupture line and an arbitrary friction angle. However, if we had a second set of data, we could plot it on the same graph, draw the rupture line, and be certain of its slope and hence its friction angle. Also, the cohesion of the soil would be known as the shear stress when there is no confining stress. Returning to our problem, we have a confining stress at failure of 400 pounds per square feet. So sigma 3 is added to the plot. The axial stress at failure is the confining stress at failure plus the deviator stress at failure. The values are plugged in, and our axial stress at failure is 1,400 pounds per square feet, and added to the plot. Next, we draw our semicircle. However, we don't have a second set of test data to help us determine the point of tangency. But we do know that the soil is sand in a consolidated drained condition, which means the cohesion is 0, and the rupture line passes through the origin of the graph. The rupture line is plotted, and the angle of internal friction is identified. For a cohesionless soil, we can solve for the angle of internal friction using this equation, where the friction angle is the arcsine of the quotient of sigma 1 minus sigma 3 divided by sigma 1 plus sigma 3. Plugging in 1,400 pounds per square feet for the axial stress and 400 pounds per square feet for the confining stress, the friction angle computes to 33.75 degrees. Looking back at our possible solutions, the answer is A.